afternoon, everyone. I'm Brandy Brown, SCTE RMC or Rocky Mountain Chapter Secretary. I'm excited to introduce to you today a webinar on AC electrical systems and infrastructure for the telecommunications industry and our guest speaker for today, who I will welcome shortly. However, before we get going, let me take you through a few key elements of the SCTE and the Rocky Mountain chapter. Rocky Mountain was recognized at the 2022 CLC Awards for 2021 achievements, in which we received 8 awards, including Chapter of the Year Award. This was all possible due to the commitment of our board and assistant board members and their dedication to the community. If you ask me why, how, might you become a member and or volunteer, I would say, because we aspire to be the best chapter in the world by enriching our lives and our members through our growth, development, and connectivity to the industry and the community. Let me tell you how to ensure you stay connected to membership and opportunities each year. First, we want to ensure everyone knows that your status annually does not auto-renew. So please ensure that you stay connected. Ensure you're logging in to verify your status. Understand your benefits that are offered through your organization, as you can see in the screen shown. Please know your membership opportunities also offer you benefits that you can take advantage of, such as complimentary and discounted membership, certification opportunities, as well as learning opportunities, the free trainings, such as the one offered today, connectivity, and access to amazing people in the industry who actively give back to individuals and the greater industry's growth and success are among a few of the benefits you will enjoy in joining SCTE. SCTE certification is the cable industry's premier endorsement for professionals. But as an added bonus, SCTE offers a certification incentive program for successfully passed exams, offering reimbursement for your out-of-pocket exam fees. And as an added incentive, reward per certification. It's a great benefit. SCTE is proud to offer industry certifications ranging from installer to engineer for all areas of the cable network. Take advantage of all opportunities to promote your expertise, advance your skills, and get certified today. Now, let's talk about how you stay connected with the SCTE community. Use your Rocky Mountain chapter to connect with people, organizations, and industry leaders to strengthen your network by utilizing the resources available with local members, industry, and the community at large. And now, finally, I'm excited to introduce our guest of honor today. It is with great honor that I welcome Ron Slutter. I did check the pronunciation of that last name. Ron is a senior technical support representative for EnerSys. During his 8-year tenure with EnerSys, Ron has focused on delivering solutions to complex power-related issues for the telecommunications industry in both AC and DC power. Ron has built his skills in the industry as a master electrician and electrical engineer. He uses that knowledge to create on-demand online training for use in the telecommunications industry. Over the years, Ron has also gathered experience in large critical facility design and construction for electrical projects, topping over $100 million. That's a big number. We want to thank Ron so much for joining us today, and now I'm excited to hand it over to him. Ron, I'll stop sharing and I'll hand the screen over to you. Thank you so much.
Thank you, Brandy. Appreciate your work in getting this put together. So thank you very much. And just let me know if you can see my screen.
Yes, we can.
All right, perfect. Let's get started. So I'm glad to be here today. So we're going to start off our discussion with the ability to use Visio to create and store what we call block single line diagrams for your facility. So why is this important and what does this help you do? This particular element helps you to create a 11 by 17, what we call block single line diagram for your facility so that it helps in many ways. One is if you're a tech and you're on site, you're on call, you're covering somebody and something happens at the site, you have the ability to grab the single line. We typically would post this in a plastic envelope on the APS or on the main distribution equipment so that it's readily available to you or to anyone. Also, if you're doing a site walk and somebody has a question about the AC electrical service or the DC, everything that you need to show someone is on site and available for you to easily get. This is not an engineered diagram, but it does contain most of what someone would need to know to be able to work on the system or facilitate adding equipment or bringing the site back up after some type of load drop. And in this diagram, we go to the next page here, we'll zoom in a little bit and we'll look at the generator itself. So let's talk about portable generator today. And ATS and whatnot. So the first thing we're going to look at is the generic locations where we can connect a portable generator to the fixed generator system. So let's take a look at it. So if I brought a portable generator in and I needed to connect to a system, we would typically do that to a maintenance manual transfer switch. Okay, and then that allows us to connect the portable generator and then transfer to it very quickly without any downtime. So that's very, very important when you're doing maintenance activities. Maybe your generator, when your fixed generator went down, you can do that in different locations and under different pieces of equipment and different connection points. So it's very helpful to know where you can connect a portable generator. In this particular diagram, we show 3 places. The MTS, we can connect to an automatic transfer switch. We can connect to a portable generation connection cabinet. I'm going to show you this equipment as we move through and give you more details related to these pieces of equipment. Okay, and the single line, the Visio single line that we're looking at has all of these in a stencil. So you can literally pull off the stencil and create very effectively your specific site conditions very quickly by just grabbing it from the stencil, dropping it into this Visio drawing, and then connecting the dots between the individual pieces of equipment. So I think that's an outstanding tool, very, very helpful to discussions regarding the electrical infrastructure in your facility. So one of the things that I talked about in the single line was the manual transfer switch. This is an example of a manual transfer switch. Really, it's an on, off, on switch. As you can see, the gray box here in the center has the on, off, on capability. So one of the on positions would be the fixed generator, and then you would connect the portable generator to the other on position, and you would simply switch between the two to perform a maintenance activity. So this is a typical piece of equipment used in telecom facilities to facilitate the maintenance and uptime of the facility, even if you take out your fixed generator. All right, so moving on to the portable generator connection cabinet. You can see here on the right-hand side, that's the inside of the box. You can see that we have some nipples that pass through the bottom to allow the temporary conductors to be routed to the box and connected to the lugs. This is something that is made locally by someone. That is not a purchased box. That's something that is put together on site. They also do have boxes that you can buy. I'm going to show them to you in a minute. As we look at each piece, you can see we have a separate ground bar, we have a neutral bar, we have the 3 phases. In this case, it's a 3-phase connection. We have a terminal block. That terminal block houses the standard needs for a portable generator. So if you needed to use that automatic start feature, all of those capabilities for the actual control of the portable generator are located on the terminal block and the portable generator connection cabinet. So here's kind of the blow up of that particular piece of equipment. You see here we have identified the automatic generator start signal, the block heater, the battery charger, and the telemetry. contacts, although they're not connected, are there for connecting telemetry for a portable generation. It's very convenient if you have a long-term downtime for a fixed generator, you're doing a replacement, whatever the case may be, you can still facilitate the installation of a portable generator and know that it's going to give you all of the alarms and start and different capabilities that are really required for that long-term portable generator. They also have other pieces of equipment that you can purchase that are a little more advanced in their capability. You can see here on the right-hand side that this particular box that can be is actually pre-configured like this and is bought with all of these features. So we have an interlock between the breakers. We have a temporary generator portable connection and a load bank portable connection so that you can facilitate utilization of CAN lock connectors to connect the portable generator or a temporary generator. What is a CAN lock connector? Well, you've ever been to a carnival and you've seen those cables running on the ground and you can see the connectors on them. They are CAN lock connectors. They simply plug together and twist, and they can carry heavy loads. The symbols here on the right-hand side of the terminal block is a CAN lock connector symbol, either male or female. So they are basically showing connections available for output or input for the terminals into the docking station for the portable generator. So this is a little bit of an enhancement that's capable to be purchased other than the previous box I showed you, which was a little less sophisticated. All right, so let's talk about the typical configuration of most sites. There are many different sites. I am giving you some very generic representations of a single generator site. One utility source, one generator connected to the ATS, and then connected to the load. Very straightforward, very simple. As we move into more complex sites and more reliability is required, some sites have a single utility service and will have two generators, each generator connected to a separate ATS, automatic transfer switch, and then connected on the output of that on the load side to the utility to gen ATS. So if I were to give you a generic description of the ATS connected to utility, that would be a utility to generator connection. We call that a U to G for short, for typical short conversations. And the ATS connected to the two generators, we call a G to G, obviously gen to gen ATS. So just to keep our acronyms short and sweet when we're doing our discussion. Here is a representation of the internal workings of an ATS. So the ATS on the left-hand side, the picture here, represents a contactor-based typical ATS design. Why contactor-based? Because contactor-based designs for ATS last hundreds of thousands of cycles. So these contacts, as you can see that are shown here, are able to withstand a lot more transfers than if we were to use the circuit breaker-based design, which I'll show you in a minute. So this is an old ASCO example, but it does show you very easily how the transfer switch works. You can see here on the left side, we have the normal connection. On the right side, we have the emergency connection, and on the bottom, we would connect to the load. This is what they look like today. On the right-hand side, this is the internal workings of a typical contactor-based ATS. So very compact, very simple to see that each one of these is a single phase. In this case, it's 480Y277. How do I know that? I know that because of the color of the wire is an industry standard that we follow. So it's a generic principle by which we can tell the voltage sometimes. Not always true, but it's very typical in the industry. You can see we have the ground down here on the bottom right, which makes this a solidly grounded 3-pole ATS. Okay. We're going to talk about that a little bit later. As we look at this picture, we can see that this particular ATS design is for a circuit breaker based transfer switch. And so behind this panel board here, there are actual circuit breakers that are connected to the lever. And when we get into a circuit breaker design, it's very different than the contactor-based design. The typical circuit breaker in these ATSs is rated for about 300 operations per year versus hundreds of thousands of operations over its life. So obviously, they are going to require a lot more maintenance and are subject to some issues related to reliability compared to the contactor-based ATS. So the cost structure of this is less, and so therefore we will find them sneaking their way into sites when the budget is of significant concern, but they are not the same as the contactor-based version. So know that when you purchase a circuit breaker-based design. What we're going to do now is we're going to talk about what different versions of an ATS. So there are many different aspects of an ATS. In reality, when we talk about an ATS, they can be very complex. They have different components that make them by a standard. This particular one shows a standard ATS. By the time we go through the next few slides, you'll be able to distinguish the differences between those different types of ATS. So in this particular situation, we're talking about closed transition. This means it's make before break. So when this particular bar moves, the handle here on this segment moves for a short period of time, usually less than 100 milliseconds, it joins the two sources together and then moves off of that to one source, to the other source. So going from normal to emergency, it will hit both at the same time, and then it will finally move off of the old source. Why do we use this? We use this to make sure that we don't drop downstream loads. However, when we do this, it can create unique issues related to the phasing. All of the sources have to be phase matched. Otherwise, we would or could put phase A to phase B, which is a dead short. So we have to be very careful. So since generally we don't use these for telecommunications in general, for ATSs, why did I bring this up? Well, we bring that up because you do use them in EMBSs. So what's an EMBS? An external maintenance bypass switch. So let me explain what I mean by that. So if we have an inverter system that brings AC through a protected DC capable inverter, right? The output of the inverter will feed the downstream load. And if we need to work on that inverter, we need to shut it off. So we have a wraparound bypass. That's this gray box here on the right-hand side that allows us to bring utility directly to the critical load. It's not protected while it's on these EMBSs, because the inverter system does have the DC protection feature, but it does allow us to take the inverter offline and work on it. So we do have closed transition devices within the telecommunications facility that allow us to transition from one source to another without dropping the load. Okay, when we move this from utility to UPS, it will not drop the load if everything's done properly. So that's where we use closed transition. We're going to move on now to back to the ATS, which is the open transition. This is used more often than obviously closed transition we rarely use. So this is a simple transition, make before break, break before make, which means when we go from normal to emergency, there is a distinctive interruption in the power between the two sources. Okay, that interruption can produce unwanted transient issues to the load. Okay, now obviously when we move from normal to emergency under the situation that we've lost normal, that's a dead transfer, right? So this source becomes dead. The generator starts up, comes online, and when this source becomes available, we transfer to the emergency source. When it becomes an issue is when we retransfer from emergency to normal. Because in that situation, we'll still have an emergency generator up and running, the normal utility source has returned and has been verified to be acceptable and available. So now we have two sources available. When this transfers back to the normal source, you will get a transient to your downstream loads. Okay, so this is not the best situation. This certainly will work. What equipment gets affected when we're in a telecommunications facility when we do this operation? Our rectifiers and our DC plane and our inverters, which are taking the brunt of these transients because those are pieces of equipment that are in the protection circuit to protect the downstream loads, whether they be DC or whether they be AC, right? So that's the equipment that's going to get those. So if you're losing rectifiers or inverters in your telecommunications facility, there are some reasons why that may be happening, and this is one of them. You have an open transition ATS. All right, let's move on. So let's move on to another standard design of an ATS, which is delayed transition. So delayed transition has two mechanisms, and it actually moves from normal to the center off position. As you can see here, this is called center off because we can go to this point and stop. So it's very different. It's physically different than open transition. So how do you get this? You have to order it. You have to order the ATS designed for delayed transition. If you do not do that, then you're not going to get it because this is a completely physically different. You cannot program open transition ATSs to be delayed. Okay. So the switch will move from normal to the center off position and then ultimately from the center off position to emergency based on the programming that's in the ATS. Once again, this switch eliminates the problem of having a transient response on the return from emergency because it will be programmed to sit on the center off spot until that load source has no voltage. And then based on the delay, which is typically around 5 seconds, it will transition to normal and pick up the new source. And that eliminates the transient that can be generated by switching directly between two different sources. All right, so as we move on, now we're going to get into a completely different kind of ATS, and this is called bypass isolation. So this is an ATS in open transition. So it's an open transition ATS with bypass isolation. So what does bypass isolation give us? It gives us the ability to manually transition without the automatic feature working. So this is something that a person has to do. So obviously, if you're in this mode, the automatic feature is not working. And so if we lost, say, the manual bypass for the normal side is closed because we lost the ATS, and we lose utility, then manually the person would need to open the manual bypass and then start the generator and see that the generator is producing good power and then close the manual bypass on the emergency side. Okay. So what does this do? This gives us the ability to deal with significant issues within the ATS without getting a rental or without getting additional equipment. We can use this equipment to still maintain service to the facility while we deal with the problems that may be associated with the automatic portion of the ATS. Okay. What do these little arrows mean? These little arrows, they don't mean the direction of current flow. They mean that the piece of equipment in this particular inside of the arrows is considered draw out. That means with power active on these circuits, we can still remove the interior portion of the ATS and work on it and then put it back in after we've maintained it. So this makes it very easy to deal with an ATS and the maintenance that's required for an ATS. There is maintenance required for an ATS. If you're not maintaining your ATSs, you will eventually run into a problem. Significant issues with grease drying up over years of service will lead to linkage hanging up within the ATS. And that's not a good thing. That will cause you to have to deal with the ATS. So this gives you the ability to maintain an ATS while it's in the midst of providing power to the load. And you can see, other than that, it's the same as a standard ATS. This is open transition, so it's going to move from the normal side to the emergency side and back and forth with no delay. Here, we're looking at what I would recommend to be most often used in the telecommunication facility. This is an ATS with delayed transition and bypass isolation. This is what you should be buying, especially for your most critical sites. We get the enhancement of having the center off position so that when we return from emergency to normal, we can let the source die before we return to normal. What is protecting the load while we're letting that happen? The batteries, whether they be the DC plant batteries, the UPS batteries, the inverter DC plant batteries, whatever the case may be, we have hours of reserve usually. Now, so a couple seconds of delay here should not be an issue. So this is the most recommended ATS I could give you for your infrastructure. All right. It is more money. There's no doubt about that. This is going to cost you money. You're going to save that money in several ways. You're going to save it on not having the transient response damaging your electronic equipment. You're going to save money in not having to provide a rental when and if you need to maintain the internal components of the ATS. So this is pretty normal because of the critical nature of what we do. We really need this level of an automatic transfer switch. All right, so delayed transition is something that has to be programmed. Okay, so I've been in sites. How do we know when the ATS is delayed or not? Well, a really simple way to know is typically the lights in your facility will tell you a lot about the transition of your utility services. So when we move from utility or we lose utility at your facility, what happens to the lights? They usually go off, right? Until that generator starts and the ATS transfers to emergency. So it could be 30 seconds, a minute, depending on what you have in your facility before the lights come back on. It's a pretty good indicator that you've lost utility power. So if when you return to utility and you hear the ATS transition and the lights slightly blink, that's what we call closed or open transition. It's not delayed. A delayed transition will turn the lights off for, like I said, recommended time of 5 seconds before they return to the utility source. So that's a good way to know what's going on in your facility and having an idea what kind of ATS. Now, there could be a situation where your delayed transition ATS is not programmed for the correct scenario. Again, there are 40 something settings in an ATS. Your person responsible for maintaining an ATS needs to be very familiar. I always recommend having OEM certified technicians work on ATSs. Typically in the industry, we see generator people working on ATSs, and they don't always get the subtleties of the requirements within an ATS. They're very good with generators. However, the ATS does not always match the manufacturer of the generator. So you could have a Cummins generator and you could have an ASCO ATS. That doesn't mean that certainly most generator guys know how to switch a generator and whatnot, but their experience with setting up and looking in a controller of the ATS and setting it up with your preferred settings, I find to be problematic. Been in thousands of sites to look at these things, so I'm probably pretty correct. So I think the industry is moving towards having OEM people perform preventive maintenance on an ATS, and I completely recommend that because of the complexities of ATS. So what do these ATSs look like? Well, this is a picture of a standard ATS. This is the inside and outside of an ONIM transfer switch, obviously. You can see on the front of this particular ATS, we have a block diagram. It's not quite the colored diagram that I showed you in the beginning, but it's a good attempt at showing what goes where and how it's connected. So that's what we recommend. We want to see that on the ATS so that it's on, you can know where it is, you know where to get some information about what's going on. So the picture on the right is the interior portion, which we talked about earlier. One thing to note here, it is never safe to open the ATS door unless you're a qualified electrician with PPE. Why? There's exposed live bus, as you can see there on the picture on the right. So I've been in facilities where they store their keys inside of this box, where they store any number of things that are in that box. They put the sometimes a hub in there that you guys need to get into. And I would caution you against that. That is a very dangerous activity to open the box and have exposed light bus unless you're a qualified electrician. All right, so that's what a standard switch looks like. This again is 3-pole. They do come in 3-pole and 4-pole switches, and I'll explain that later. This is a bypass isolation. As you can notice right away, it's much larger. And it has a lot more handles and things going on. And so you can see the picture on the left-hand side has the typical block diagram, and this is one of our block diagrams that, again, we put on the facility. Now, I would prefer this to be a plastic envelope with multiple copies because that way people can take them with them. So that would be an enhancement that we would expect to see to this. You can see here that we have some single line information about how we have the sequence of operation. Okay, we have a lot of information on the front of this ATS. And again, on this one, sequence of operation, we have voltages, we have ampacities, we have a lot of switches. This is why I always recommend that the certified OEM people come to deal with these ATSs because they're getting more and more complex. The controller that you see right here, this is an ASCO 7000 controller, are not the easiest thing in the world to program because you have to know what you're doing. They have a password, so they need some special attention. All right, moving on, let's talk about some of the industry requirements that are now coming into play because of capacity improvements in the infrastructure. If you've been around, you know that the electrical services in your facilities have been upgraded and upgraded and upgraded, sometimes 2, 3, 4 times. So we are now getting into a situation where people are requiring 480 wide 277 volt 3-phase 4-wire to feed the amount of capacity that's required in the facility. When you get to those levels, okay, so let's take a look at 210.13. This is out of the 2020 NEC code. It says each branch circuit disconnected rated 1,000 amps or more and installed in a solidly grounded Y electrical system of more than 150 volts to ground. So this is the key right here. A 480Y 277 volt system is more than 150 volts to ground. So because of that, code requires it to have ground fault protection. Okay. So once you get above 1,000 amps at 480Y 277 3-phase 4-wire, you need to provide ground fault protection on the main service equipment. So that's expensive and it's required if you have that service. There's no getting around it. And it is because services that are this much ampacity have the ability to do what we call burn down. In other words, a low level fault still has enough capacity to burn the equipment to the ground. So what we do is we put a ground fault protection system so that it can see that low level fault and disconnect. But in a telecom facility, we don't want that to happen. We don't like ground fault because it affects our reliability. So how do we deal with that? I'm going to show you some answers to how to deal with that, but just keep this in the back of your mind. So here's 230.95, which was talked about in the previous code related section, and it says the ground fault protection shall be provided, right? It has to follow all of these particular, I'm not going to read all of this, obviously, but it's saying this is how we ground fault protect equipment, okay? And then when we ground fault equipment, we also have to provide performance testing when we use ground fault equipment, required by the code. These are new code sections that are often missed when upgrading facilities to new and larger capacity because we haven't seen that kind of capacity before. So people get used to doing things the same old way. And this is not the same old thing. When you upgrade beyond 1,000 amps, you really need to make sure that your design has been configured properly. We're going to talk, I'm really not going to get into the weeds with that, but basically you need a power study for your system. And that's basically engineering. You have to have a system engineered when you get to this kind of level of system. So here's an example of a 3-pole ATS. You can see here we have a transformer, we have a ground fault, a circuit breaker on a 3-pole system. And if we were to do that, there's the chance that we can get, with a solidly grounded system, we can have circulating ground current that can produce a nuisance trip environment. Okay? So how do we get out of nuisance trips when we have a solidly grounded ground fault system that we need to install? The way that we do that is we have to install a 4-pole ATS. Notice the difference between this is the 3-pole. The neutral is solidly connected together. We move to the next screen, we can see that this is the 3-pole ATS, but the neutral is also switched between the two sources. And this creates some very specific changes that are required if you use 480Y277. I'm going to show you how to get around that in a few minutes, but for now, know that this creates an environment where you have to spend a lot more money because you need a 4-pole ATS rather than a 3-pole. You've got to have a ground fault protected main service. You actually have to do additional steps to the generator as well. You need to do a ground fault alarm on each circuit breaker. So there's a lot that has to happen if you get beyond a particular capacity. Here's what we recommend for you to do to get around all of that and to have a more reliable system and less money. For services that are 480 volt above 1,000 amps, the neutral conductor is not utilized. So we no longer use 277. Only the ground wire is brought from the center tap. So instead of this being the neutral conductor to the building, this is a ground wire, and that's it. There is no neutral to the building. We do this very specifically. No ground fault protection is required when we eliminate the neutral. It's less cost and it's more reliable. So if you've ever been involved with large data center services, this is what we do for large data centers. When we go over 1,000 amps for a data center, we switch to 480 3-phase 3-wire, no neutral. And we still use a delta to Y transformer for the service. However, we don't bring the neutral into the building. Okay? Why? What do you need a neutral for in a telecommunications facility? There are only really two things that typically fall under that category potentially, and that is rectifiers and lighting. Okay, how do we get around the rectifiers? We order DC plants with 480 volt 3-phase 3-wire rectifiers, which are available. You just have to make sure that the design incorporates that requirement. If you did need lighting at 277 volt, which you can obviously get around as well by using 120 volt lighting, you could put in a small transformer to derive a neutral without and eliminate huge hundreds of thousands of dollars worth of main service cost to pick up a small transformer just to do the lighting. So this is very important for you to recognize this. Right now in the industry, I've run into this year maybe 3 or 4 of these services that have not been configured properly, and they're spending a lot of money to fix the issues related to that. So make sure you get your engineering and your power study first. So if you were to use a system that is a typical system, so 99% of the systems that you have are this, where the generator is solidly grounded to the ATS and the main service. So there's one neutral to ground bond right here. Okay. And that's pretty much how most should be. Now, in a generator, if you're standard like this, and you see a neutral ground bond in the generator, that's probably inaccurately installed. Why does that happen? It happens because every generator is shipped with the bonding equipment. Okay. So an electrician will find this screw or this jumper in the side of the circuit breaker cabinet, and he'll go, oh, I must have to install this. And so maybe 20% of the sites I go to, I find that this generator is neutral ground bonded. That can cause problems. Okay. You get circulating ground current. It's unsafe. Okay. Causes an equipment and a safety problem when we run into these situations. So there should only be one neutral to ground bond in this service equipment related to bonding a generator. When we have to use it, a 4-pole ATS, notice that the difference between these two ATSs that are shown. So this is a solidly connected neutral. On this side, we see that the neutral is switched. Okay. And when we switch the neutral, now this is larger critical facilities, right? But these are the sites that matter when we get into these kinds of environments, right? Notice that when we have a 4-pole ATS, then the generator has to be bonded. So we have a bond in the service equipment, and we have a bond in the generator. These are very important considerations that change, again, based on that increasing capacity requirement over 1,000 volts at 480. Okay, so make sure that you understand that when you reach that threshold, you've got to have very different elements within the electrical infrastructure. So now let's talk about the sequence of an automatic transfer switch and make sure that you understand how these work. So first of all, we sense the interruption of utility power. And do we instantly start the generator? The answer is no. We wait for some period of time, most likely around 15 seconds, because what are we on when we're waiting? We're on battery. We got plenty of battery capacity. We have 2 hours of battery, and most people have at least that. So 15 seconds, no problem. We just let it ride through on battery. Once we get past the 15 seconds, we send a start signal from the ATS to the generator, and we let it warm up and stabilize. Once the ATS senses that the generator power is good or available, it's electrically stable, we transfer the load to the generator. So once we transfer to the generator, we've been on generator for some period of time, generator's running fine. All of a sudden, the utility power comes back. So the ATS senses the return of utility power. It can sense the return, and it can be stable or it can be unstable. What does that mean? So you can have situations where the power return for the very first time, but we have tree limbs all over the utility lines, and the power is fluctuating. The phases are going off and on because they're trying to clean up these issues on the power lines. So it may be stable or it may be unstable. There's a period of time, usually 15 to 30 minutes, that we expect the utility has to be stable. And once it's stable for that period of time, the ATS can say, okay, now we're ready to retransfer the load. Now, I can tell you this too. I've seen situations where the utility was back, but it was unstable. So although you looked at the front of the ATS and it said utility had returned, it did not consider it stable. So it was still losing phases. The voltage was still messed up. And it took 24 hours, sometimes 2 days, for them to clean up the utility enough for it to be stable. And during that period of time, the ATS would not retransfer. That's okay. That's an environment in Florida where they have there's hurricanes and there's much damage and whatnot going on. But once it's deemed to be stable, the load will return to utility. Then we'll send a stop signal to the generator, allow the generator to cool before shutdown. Why do we let the generator cool before shutdown? And there's a very specific reason. Most generators, diesel generators specifically, have turbos. And if you are at a very high load on a diesel generator and you just shut it off after you had all this load on there, there's a good chance you're going to fry the oil in the turbo or boil the oil. So The same reasons why you see big trucks when they're pulling up a large mountain. They get to the top of the mountain, they don't shut off the truck, they just idle to allow the equipment within the truck to cool down before they continue their on the road. So it's the same premise with the generator. We need to let it cool down before we shut it off. And that is pretty typical. All right, so now let's talk about diesel fuel for your generator. So what we have here is a picture of the internal portion of a tank, and the red line representing the top of the fuel, the blue representing the area that can contain contaminants. So you look at the glass here on the right-hand side, we have an area of water. We have this area where we see there's something going on here. It doesn't look good. This is pretty typical in fuel tanks that are not taken care of well. We have contaminated diesel fuel in the bottom of the tank. If this were allowed to continue, and it will continue until you get it removed, and it does happen on almost every tank. Each tank will deal with it a little differently, but because they changed the requirements of diesel fuel in the industry, they've eliminated a lot of additives that allowed this to be this process to slow or whatnot. You need to deal with this. The first step in dealing with it is understanding what's going on. So if you do not specify the use of a specific tool, and I always laugh when I read this because I don't know why they call this tool a Bacon bomb, but that's the right name. It's not a mistype. Okay. If you search for diesel Bacon bomb, this is the tool you're going to find. This tool goes to the bottom of the tank, and you put a screw in the bottom to set the where it will take the sample off the bottom of the tank. This is what you need to do. If you're not currently doing this to sample the fuel in your sub-base fuel tank of your generator, you're just waiting for disaster, because I will guarantee you, you're going to learn a lot when you specify the use of this tool in your facility. Most of the time, generator guys are going to push a little white tube in here and pour oil or fuel out with a little plunger, and that tends to just curl up here in the top and take fuel that's at the top of the tank, which is almost always going to be good. Okay. If the fuel up here is bad, you've got a real problem. Okay. You need to make sure that you're asking for the use of this fuel sampler from the bottom of the tank. Very important. So now let's say that we have our fuel sample, and we need to deal with the problems that we've identified in the tank. Here's our sample. Doesn't look very good. We need to get it to look like this sample here on the right. This is called polishing. So what we do is we're removing the fuel from the bottom of the tank where we have this water layer. Okay, we're pulling it out of the system and we're running it through this series of filters and putting it back into the tank when it's clean. And so we're trying to stir it up and eliminate the fuel that is contaminated. Now, what you see here is an input and an output, right? Not every tank has two fittings. Some of them are always one fitting. Okay, so if you have one fitting in your tank, and it's a small tank, you probably can still perform this fairly well. Hopefully you're mixing it up enough. What you don't see here, that is true for almost every sub-base fuel tank, is there are baffles in this tank, and they are almost complete. Every 2 feet, there's usually a large steel plate from top to bottom. How they let the fuel transition between those plates is they cut the corner off when they weld the plate in. And so there's only a little triangle on each corner of the plate that holds up the weight of the generator that allows the fuel to mix between these different segments. So if you only have one input port or output port here, and you're only able to clean it through that you're only hitting one of the segments of the tank. So it's important when you buy a diesel fuel generator to have two ports. Now, some of the generators that I deal with are very small, and it's hard to clean a tank. Well, it's actually easier with a small tank, but some of the generator tanks I see are 20-foot long, right? So you definitely need two of these ports. Otherwise, you need to get a tank and you need to pump everything out and then pump everything back in until you get rid of all this contamination in the bottom of the tank. Very elaborate. So do yourself a favor. When you get to larger tanks, make sure you order 2 tubes to get into the tank. So let's talk now about a little bit about framework grounding. What is framework grounding? It's the DC ground, the MGB that you see in your facility. What is it rated for? It's rated for hundreds of thousands of amps. Why would I say that? It's rated to get rid of lightning. That's why there are 2 holes in every ground connection. And if we have a 90-degree turn in a conductor that's supposed to be, like, so this blue line should really be green, right, representing the green grounding conductor. If we have a 90-degree turn, notice that that doesn't work for hundreds of thousands of amps. Okay, keep in mind, lightning could be a billion amps. Okay. So what do we do to install grounding properly? We put a radius on all of the bends. So in your facility, you should have a nice 12-inch radius on all of your grounding. If it's a U, it is a choke. If it is a 90-degree bend, it is a choke. And all of that should be in the direction of flow. Notice the direction of current flow here. What do you see that's wrong with this? Well, obviously, there's some problems here, right? Tie wrap's not going to cut it. Excuse me. We have back-to-back fittings. We have fittings without a inspection port. We have too much grease being utilized. We have no lock washers on these connections here. We have short barrel fittings. All of these are generic, typical installation issues that we see with this picture. Also, when we're doing grounding, we need to have in and out capability. This particular bar only has 2 holes, right? What we really need is a bar that has 2 holes in the bottom, 2 holes in the top to allow current to come into the bar and be absorbed. So we have producers and absorbers. Producers and absorbers can't be on the same side of the bar. On this side of the bar, we have producers and absorbers. So if this is a producer and this is an absorber, if this produces 100,000 amps of lightning current, that 100,000 amps is going to be induced in this conductor right here. Okay? And so this becomes a choke. This will not allow that current to flow out, even though it's an absorber. So the installation practices that you have for your grounding are extremely important. If you don't capture this when all of the grounding is installed and you get a lightning strike near your building, you're going to suffer extensive damage. And you're going to say, I've got all of these ground conductors installed. Why is it not working? It's not working because of the chokes that are in your existing system. I see this everywhere. Just give you a few examples. Okay, this is a bar that has 2 set of holes, right? But look where all the connections are all on one side. They're all next to each other. So producers have to come in and absorbers have to go out without being next to each other. Very, very important. A typical continuity test is not going to show this. You put 100,000 amps of current flow on this ground bar and it will not work. Same thing with this one. We got a big choke here going into the conduit. This actually turned into an RF antenna and injected all the RF signal into the ground system and was disrupting load all over the place. Here you can see very obviously we have an absorber, this larger conductor, and all of these producers, but they're right next to each other. Again, it will not work. Outside, we have a U in an outside ground rod. This is the ground rod here. This is a choke. So this will disrupt the flow of the current into the ground rod, and it will not work. Again, if you read a ground resistance test on this ground rod, this wouldn't matter because it's all low voltage to read that test. But if it got 100,000 amps put on it, it will not work. Here's an exterior connection. This is a split bolt. This will never work. I tested this. This had 220 ohms of resistance between this conductor and this one. It was, although it's bolted together, it does not have continuity between the two sufficient to get rid of a significant surge. Here you can see a mechanical lug that's connected to a tower, right? Once again, this had more than 300 ohms of resistance between this conductor. Looks like it's grounded, but it's not working. You have to do testing to know what's going on. Here's a ground rod that's been in the ground for 10 years. ground rods do not last forever. They have a finite period of time. Here is some material and soil types, right? So look at the difference between straight copper, 100% conductivity, and a typical copper-clad steel ground rod. Look how low the conductivity is of that particular typical ground rod, right? So not as good as you might imagine. Look at the different types of material, how much the resistivity goes up based on what material you're putting your ground in. So you need to know what it is to know how well it's going to work. If we're in a dry environment, resistivity goes way up. Look at the moisture content. As it goes down, the connections become worse in different types of soil. If water freezes, so here's a very important one. If you put your ground ring in around your building and it's not below the frost line, then when the ground freezes, you lose your ground ring. You've lost your ground because it's not buried below the frost line. So very, very important. Make sure the top of your ground rod and your ground ring are below the frost line. In some situations, that can be very hard to achieve. To get around that, I say use a chemical ground rod. So this is 100% copper tubing, 3 inches wide, goes all the way to the surface, gets you below the ground, frozen depth, and install a trench with this type of installation. This is a cost-effective way to get very good grounding. So you can see a reference between a typical 10-foot ground rod and a chemical rod, significant enhancement in its capability. And it only gets better with time. It doesn't wear out like a typical ground rod. So this is a 10-foot, 20-foot, and 40-foot installation. With a 40-foot installation, we can get down below 2.5 ohms. Typical ground resistance measurements now are typically 5 ohms or less. That's what we're looking for. Here's an example of a installed AC disconnect, which had, you know what, I think I'm going to stop here because it's going to use up all of our time. So do we have any questions? Is there anything that you guys have? By the way, here are the issues if you're interested. Very bad installation. Do we have any questions that we need to address?
This is Nick. I put one in the chat window.
Okay.
I can also verbalize it if you want.
Yeah, let me open the chat window here.
Okay. I'm happy just to ask it if that's okay.
Go ahead.
Well, first of all, just thank you for the tips on the generator specialist to perform ATS maintenance. We have similar other issues that occur in other areas. But anyway, the question is, what are the consequences of not performing preventive maintenance on my ATSs? Specifically, is it possible that I might have an issue that develops that I have to plan for a hard down to repair? I mean, could that get that bad?
Yes, they absolutely will. So we've had situations where the screws were not tight in the linkage, and this just happened maybe 3 months ago. So 2 screws became loose over time, and the ATS just would not transfer. We've had issues again where the grease has dried out, and when the grease dries out, the linkage hangs up. Then we've had issues with not testing some of the components within the ATS, and they're failed, and because they're failed, it will not transfer. So a lot of people don't understand the complexities of needing preventive maintenance on an ATS. But once you get into the 10-year mark, you're going to find out pretty soon that there are issues because of all of these different things that can happen.
Thank you for that. Let me pause and see if anybody else has one before I ask my next question. Okay, I'll go for it. I'm familiar with EnerSys code, whereas if you don't achieve 25 ohms ground with an 8-foot ground rod, you could put them end to end and go deeper. But does anybody get away with that? Like, I've never, I can't imagine that actually works.
I've never seen anybody do it, ever. So this is one of the reasons why I talk about chemical ground rod, because it's a one and done thing. It only gets better. It doesn't get worse. So whether you are, if you, as long as you're below the frost line, and it does require maintenance. It comes to the surface of the ground, which allows you to test it, right? If I have to bury a ground rod, let's say I'm in North Dakota, I could have to put that thing down at 40 something inches. How do I get down there to test it? You're going to have to put in a manhole to get down to the ground rod to do testing on your testing intervals. You're not just going to be able to bury it. So there are significant enhancements to the capability and the maintainability of using a chemical ground rod to achieve less than 5 ohms, which is the SCTE standard that's coming recommendation. So yeah, it's very helpful all the way around. There's lots of other enhancements I could offer to increase the functionality. Most people hardly ever see a direct lightning strike. Now, direct lightning strike, there's not a whole lot you can do, but what you're going to see is most likely a tower by your facility. It hits near your facility and it's trying to get rid of that excess capacity. It doesn't have the ability to do it because it's impossible to test your MGB at 100,000 amps, right? We do a low voltage test of your system to see the resistance values, but when it gets that much ampacity impressed on it, you're going to find out whether it works or not. And I've seen $2, $3, $4 million worth of damage in a facility.
Wow.
I will take it.
Thank you for that. And since you can hear me okay, I'm going to go ahead and read the question from Jason Billings. There's a couple more behind that. Don Bowman, I think it is. If we want additional training, do you offer training courses?
Yes, we do. So here at EnerSys, we have training that we offer online, on demand, that is available to you as a customer. You have a specific code related to a coupon code. So some people pay for it, some people don't, quite honestly, depending on your volume of sales with our company. So you can work that out with your local salesman. Talk to him about getting the capability to use that. But we do a lot of training for charter. We do it on demand, and we also do it in Swanee, Georgia. We have a facility where, similar to the equipment you can see behind me, we have all that equipment, and we train on our equipment in that facility very extensively. So
fantastic. Yeah, appreciate that. And we'll, I think, provide links. Well, besides your PowerPoint, there's going to be other references to get to those training courses. So thank you for that. Mr. Andrew Go, he writes, what is the chemical used in chemical ground systems?
So it's a bentonite clay, and which is basically a form of salt. And so that salt uses water, and it leaches from within the tube into the, could be even bedrock. And it will create a ground using those salts to facilitate it, even if you have very poor soil. And like I said, over time, it continues to build those roots that you saw in the diagram to create a better and better ground. So very different than a ground rod, which you basically, once you put it in, whatever it has, right? It barely doesn't vary very much. So it's a much better insulation. There are many different manufacturers. I'm only showing one of the many different types of ways that can be done.
Thank you. And Don asks the second question. ATS is a mechanical device with moving parts, so does it need to be lubricated?
Yes, it absolutely has to be lubricated. Yeah, it is part of the typical preventive maintenance. Again, getting into having an OEM come in, they know what they need to do. And that they should dictate the MOP to do the preventive maintenance based on the type of ATS. So even within ASCO, there are different requirements for preventive maintenance based on the model, right? So each ATS needs something a little different.
Don, I'm hearing, don't try this at home. 3-1 oil,
Yeah.
bearing grease, no. Okay, I have another question. It is, you were talking about surge producers. Can you provide a few more examples of surge producers? Where's, I mean, I'm
So,
thinking of satellite dishes or chain link fences.
so the basic concept that I was referring to is called panning, which is producers, absorbers, non-isolated, and isolated. And the producers are things like an aisle ground, another bar, right? So basically your equipment goes into your aisle ground feeds back to your MGB, that's a producer. An example in an absorber would be the ground ring itself, would be a water main, would be the building steel, all of your main ground points. So really what you have to do is configure the bar so you have inputs and outputs. And they're not just, if I walk into a facility and I see everything on one side, which I see most of the time, I can instantly tell you that it's not set up right. And unfortunately, if they're installed in the building, they're usually very hard to fix because they're either in the concrete, they're routed all the way through the building together, right? So you really need to get that at time of installation to make sure that that's done right.
Is it okay to have an external ground ring and put towers and fences and satellite dishes on it and then just bring it into the building one
Well,
point?
so the general rule is if it's outside, keep it outside, which is why we have the ground ring around the building. So I'm completely fine with you bringing a fence to the ground ring outside, your HVAC units down to the ring that are outside. Your generator ring should be tied into the ring around the building. The tower grounds should be tied to the ring. Your AC service should go out of the building to the ring and not to the MGB. Because we want it to go out to where it will be absorbed before it will be distributed to the equipment on the MGB. So general rule, just if it's outside, keep it outside. And yes, we do, they all by code have to be tied together. That is a code requirement that they're all tied together. You can't have a DC ground and an AC ground.
Perfect. You mentioned freeze line. If I CAD weld my ground ring 2-aught cable to the ground rod, do I need to go under the freeze line, or is that?
Absolutely do, because what you'll find is just like that picture I showed, you'll get somebody who brings, let's say they put the conductor down at 48 inches and the ground rod's up at 2 feet. They rarely bend it with the right radius, and you just lost 2 foot of your 8-foot ground rod to the frost, right? So if you bury the ground rod below the frost line, what happens to the conductor? It goes straight over the top of the ground rod and then is exothermically welded so that it's just a T, right? And it continues on without that disrupting choke. Most of what I see is in a 6-inch PVC tube, and they put the ground rod in and then they shove the 6-inch pipe over top of the wires, and it's a big fat choke.
That helped a ton. I thought it was related to the acorn clamp coming loose, but it's much more than that.
Yeah. We don't recommend acorns in this environment. Everybody that I know is exthermically welded outside.
I don't use them. I don't know why you saw that. Okay. Does anybody else have a question? I don't see any in the chat, but Andrew, do you know of any that came in? I do want to know if the bacon bomb tool is available for my body. Like, is there a version of it?
You can Google that. I'm sure it'll tell you.
All right. Andrew or Randy, anybody want to close this down?
I'll stop sharing.
Okay. Andrew, I see you're off mute. Thanks.
As far as I can tell, we have nothing else unless Brandy has some last words.
Well, I just want to thank everyone for joining. I am not positive how we would normally close out, but Ron, I want to thank you for being here and for letting me introduce you today. And if no one has any further words, we thank you all for joining us. And if you're not a member, please ensure that you join. We'd love to have you join us and support Rocky Mountain chapter. Thank you
Huge. Thank
again.
you, Ron. Yeah, very good.
Very glad to help.